Okay, let's look at some simple if statements first. This one just has an if with a condition. If this condition is true, it will execute this statement and then go on to the next line. If the condition is false, it will skip that statement and go on to the next line. Next comes if else. This condition is true, it executes this statement, skips the else and goes down here to the next line. This condition is false, it's going to skip statement 1 and go down to the else, execute this statement, and then go on to the next line. Okay, this one's a bit more complicated. This works in the following way. You come in here, if this condition 1 is true, you execute statement 1. Then you check condition 2. If it's true, you execute statement 2. Check condition 3. If it's true, you execute statement 3. This can become a little more useful, perhaps, if these three conditions are mutually exclusive. Let's take a look at that next. So here the three conditions are x is equal to 0, x less than 0, or x greater than 0. You can see those are mutually exclusive. In other words, if this one's true, then neither of those two will be true. In this case, when you come into this if structure, you'll either execute statement 1, statement 2, or statement 3, depending upon the value of x. This can be very useful. Okay, so this one's a bit more complicated. If condition 1 is true, you execute statement 1. If it's not true, we come down here to the else and check condition 2. If condition 2 is true, we execute statement 2. If not, we jump down to the else and execute statement 3. So this is easy as well, except you must be careful with the order of the conditions. Once one of these conditions is met, the corresponding statement is executed, then the program jumps the remaining conditions. So you must be careful that if condition 1 is true, it does not jump any other conditions that you want to have checked. Now let's take a look at this one. Here we're going to check condition 1. If it's true, we'll check condition 2. If condition 2 is true, we will execute statement 2 and then jump to the end. If condition 2 is not true, we'll go down here to the else and execute statement 3 and then go to the end. If condition 1 is not true, we skip over all this stuff and go down to the end. In this case, the compiler associates this else with the nearest if, which is this one. So these two things go together, and this will skip over that entire statement down here if condition 1 is not met. Here we put in some brackets to change the else to be associated with this first if instead of the second one. In this case, if condition 1 is true, it checks condition 2. If that's true, it executes this. If it's false, it's going to skip and go all the way down to the end. On the other hand, if condition 1 is false, it's going to skip down to this else and execute statement 3 and then go to the end. Now suppose you want to do something even different than that. If condition 1 is true here, check condition 2. If condition 2 is true, execute statement 2. If it is false, go down to the else, execute statement 3. If condition 1 is true, go down to this else and execute statement 4. Again, the computer associates this else and this if since they are closest together, and then that else is associated with that if. This can be clarified by placing brackets as shown here, so that these two statements are associated together since they're within the brackets, and then that's associated with that. Brackets can always be used to clarify exactly what it is you want to do. Okay, let's take a look at an example of a program you might write. Suppose you're developing a program to control the warning signs at the exits of major tunnels. If roads are slick, road status equals S, you want to advise drivers that stopping times are doubled or quadrupled depending upon whether the roads are wet or icy. Your program will also have access to current temperatures in degrees Fahrenheit, so as a check as to whether the temperature is above or below freezing would allow you to choose the correct message. So here's what the block diagram would look like for that. Basically, we come into here and check the condition S. If it's true, meaning it's slippery, we'll go over here and check the temperature. Greater than 32 is true, we will say wet roads. If this is not true, then temperature is less than 32, we'll say icy roads. And if condition is not S or slippery, then we'll just say drive carefully. Next, we'd like to look at what this would look like in terms of code. So here's the program. We have all the typical stuff, some documentation, include stdio, int main void with a bracket here and a bracket down here on the end after the return 0. The main program is going to ask the user to enter either G or S and the temperature in degrees Fahrenheit. We'll come into this if statement and then check. If road status is S, we will then check the temperature. If it's greater than 32, we'll print out wet roads ahead, stopping time doubled. Less than 32, in other words, this isn't true, we'll go to the else, print icy roads ahead, stopping time is quadrupled. And then if this first statement is not true, we'll go down to the second else and just print out drive carefully. Okay, let's go ahead and compile this. We'll go to build, say build solution, and then we'll run it. We'll say debug start without debugging. So here we want whether it's S, we'll say it's slippery and 15 degrees, and then it says icy roads ahead, stopping time is quadrupled. We want to run this again. Go back to debug, start without debugging. This time we'll say that it's slippery and 38 degrees. So it says wet roads ahead, stopping time doubled. Now we'll check one more thing. We'll go to debug, start without debugging, and this time we'll say that the roads are good and it's 15 degrees. Now it just says drive carefully. So we see that the program works as we desired it to.